Hi everyone, in this video we will see the ADDIE model and CDIO model. ADDIE model is a systematic instructional design framework used to develop effective educational training and e-learning programs. So it provides a structured process to ensure that the learning objectives are clearly defined, learning materials are effectively designed, and training outcomes are evaluated based on the continuous improvement. The model consists of totally 5 phases. Analysis. Analysis means identifying the learner needs, goals and requirements. Then the second phase is the design phase. The design phase, the planning, learning objectives and content structure, teaching methods and assessment. The third phase is the development phase, which is basically creating and producing the learner material and resources. In fourth phase is the implementation phase. Implementation means delivering the training or a course to the learners. Then final phase is the evaluation phase. In evaluation phase, we are going to assess the effectiveness of the training and making improvements based on the feedback and the performance result. So if you consider an example, determining what BTech students need to learn in RISE and Actuators lab. So in analysis phase, first what we need to do is we need to identify the learning problem in RISE and Actuators lab, what is the goal and what are the objectives of learning that lab. Then second, we need to understand the target audience, whether this lab is useful for students or a trainee. First, we need to identify the target audience. Then we need to analyze available resources and constraint for executing the RISE and Actuator lab for the particular target audience. We need to check the availability of resources and facilities and also the constraint. Then we need to define what learners need to achieve after completing this lab. So this ADDIE model is widely used in education, corporate training and instructional design because it's organized and learner-centered approach to course development. The second phase is the design phase. In design phase, first we need to plan the learning objectives and outcomes. So for example, the trainee or students are given the assignment to design a lab experiment for Actuators and RISE lab. For this, they first do planning and learning objectives and outcomes. The second is they need to have a structure. Before you are executing any courses, we need to have a proper structure of course content and how you are going to make the sequence. The lab consists of 10 to 12 experiments. You need to plan accordingly. What are the experiments are required for the beginners to learn. Then we can go for the advanced experiments. Then coming to the third point, it's decide the teaching method. So either you are going to give a lecturer type of teaching or lab-based teaching, or we can give some activities for this particular lab. Then we have to design a assessment strategy. This is very important point. So whenever the course is executed, we need to plan the assessment strategy. So the assessment may be either the lab-based, project-based assessment, or this lab maybe consist of 3 assessment, and finally the average can be taken and it will be evaluated for giving the course completion certificate. So like that, we need to first plan how we are going to design the assessment strategy. So next is the development phase. In development phase, we have to create and assemble the actual content. So for example, building a lab kit for stepper motor experiment. So the students or a trainee has to create and assemble the actual content, whatever given to the students. Then develop the material like manuals, videos, PPT and kit, and prepare the lab setup or prototype. So next is the implementation phase. In implementation phase, we are going to have a conducting the lab session and guiding the students. So the trainer, the people who are in the lab will deliver or conduct the training or a course. The faculty may be useful for giving the training to the students or the training. Then they need to facilitate the learning. So they have to teach, demonstrate, and also they can have a lab-based training. Ensure all this material and tools are used properly. In the implementation phase, they need to ensure all the materials, whatever given to the trainee, has to be used properly. Okay. Next is the evaluation phase. In evaluation phase, we are going to conduct the practicals or a test to assess the learner performance, and also after completing the lab course, the student you need to collect the feedback. The student should give the feedback. So collect the feedback from the students and the instructor and the trainee, then improve the course based on the feedback. So it's a continuous process. So based on the feedback, again we need to modify if the content need a modification or it need to get updated. So based on the course feedback only, we can able to design this course material change. Okay, so reviewing the students' result and refining the list of lab experiment. So this is the example of ADDIE model. We are asking the students to develop a ball balancing system. It's a control system project. The ball has to get balanced on the beam. Okay, so assume that the students are having a lack of understanding about the feedback control system. So this is the analysis we have made. The students are not having thorough knowledge about the feedback control system. So what is the design phase we are going to do is, in design we need to first clearly give the objectives. The objective is maintain the ball at a center using PID control. So we are going to develop a closed loop or a feedback control system for maintaining the or keeping the ball at the center position. Okay, so the objective is clearly defined. Maintain the ball at the center using a closed loop or a PID control. Now we need to plan what are the sensors are required for developing the system: sensor, actuators, and controller. So for ball balancing system, generally they use ultrasonic sensor to measure the ball distance on the beam. Then using servo motor, the beam can be actuated, and finally the ball can be maintained at the center position with the help of a controller. The next phase is the development phase. In the development phase, the students has to build up the setup. So as I already mentioned, generally the ultrasonic sensor is used, and also we can use IR sensor for sensing the ball position. Okay, based on which the servo motor is actuated and the controller will be adjusting the ball at the center position. So for this we need to do a PID controller code. So write the PID control code, and during implementation phase the students should tune the PID values and observe the overall system stability. So there are a lot of methods are available for tuning the proportional, integral, and derivative gain values. And also students can do a random changing of PID values, and they can clearly observe how the system is performing. Either it is increasing, the overshoot it's coming, or system stability is not, it reaches to zero, system is not able to stable, or undershoot will be there. Okay, so all those things they can observe by changing the PID gain values. So in order to bring the system stability, which means the ball has to come at the center position, they have to give an optimum proportional, integral, and derivative gain values to the PID controller that they need to identify based on the random process method, or they can use a structured approach. Then the final phase is the evaluation phase. In evaluation phase, they need to check the accuracy and the response time. How quickly this ball is getting settled in the center position. It should not get overshoot or undershoot. The ball has to oscillate initially, then it has to come back to the center position. So that response time is very, very important to see the system is to check the stability of the system. Okay, we need to check the accuracy and also the response time and improve the design based on the student feedback. So if anything need to be modified in this particular design, so get the feedback from the students and we can modify the overall system design. Before applying ADDIE model, first we'll understand how the scientific method and engineering design process works. So the purpose of scientific method is to understand and explain the natural phenomena, whereas the engineering design process basically is to solve the problem and create a solution or a product. Scientific method basically focus on discovering the knowledge and principle, whereas an engineering design process development of practical solutions. The starting point for the scientific method is asking questions about the nature. For example, studying why the material expands when it gets heated. In engineering design process, identifying the problem or a need. And scientific method is based on hypothesis and experimentation. This engineering design process approach is based on design, building, and testing. So this is the steps involved in scientific method. First have observation, then hypothesis, experiment, analysis, and conclusion. Whereas engineering design process, first you need to define the problem, then do the brainstorming, design, build, test, and improve. Coming to the scientific method, the outcome is basically a theory, law, or explanation. In engineering design process, the outcome is a product or a system or a model. Scientific method is more rigid and structured, whereas the engineering design process method more iterative and flexible. So the example given here is the scientific method studying why the material get expanded when it gets heated. Whereas engineering design process, designing a temperature sensor system for this application. Now we'll see how to apply this ADDIE model in scientific method and engineering design process. In scientific method analysis, basically what we do is identifying the scientific questions about the natural phenomena. Whereas the analysis for engineering design method is identifying the real world problem or a need. Then design a scientific method from the hypothesis and plan some experiment. In engineering design process, we have to plan possible solution and design the system or a product. Then the development phase, in scientific method, conduct experiment and collect the data. In engineering design process, development is basically to build the prototype model of the solution. In scientific method, the implementation is performing the experiment and testing the hypothesis, whereas engineering design process, the implementation is applying the test, the design the solutions. In scientific method, the evaluation is basically do analysis of result. Either we can accept or reject the hypothesis. But engineering design process, we have to evaluate the performance, and based on the performance, we have to improve or redesign the overall system. So next is the CDIO model. The CDIO model is basically suitable in engineering education framework that focuses on teaching the students how to develop a real world system and product through a complete life cycle approach. CDIO model means it has four phases: conceive, design, implement and operate. So basically conceive means it's a problem identification. You need to understand the customer need and the market demand and analyze the feasibility and the constraint. For example, identifying the need for automatic conveyor in a factory. So this is a problem identification. We need to identify, understand the customer need and market demand, and also analyze the feasibility and the constraint of automatic conveyor system in factory. The second phase is the design phase. The selected concept is transferred into a detailed design. So the engineers should prepare the specification, drawings and simulations and the plan that describes how this product or system will be built. For example, designing a conveyor with the system, you need a motor, sensor and control system. So you need to select the components and the tools required for simulating this conveyor based system, and also what the methods we are using for developing this system. So this should be carried out in the design phase. Coming to the third phase is the implementation phase. In implementation phase, the design is converted into a real product or a system. So this phase involves the manufacturing, coding, testing, assembling and integrating the components according to the design specification. So in this example given, installing the motors for conveyor and the control, we are going to use a PLC based control and we are going to use a sensor. So this sensor should be integrated with the controller and you need to give a proper wiring of the system. So in implementation phase, they are going to develop assembly of the system. They build and integrate the entire system with the sensors, actuators and control with the proper wiring. The fourth phase is the operate phase. The completed product or a system is used in its intended environment. So the engineer monitor the performance and maintain the system and evaluate the result and make improvements based on the operational feedback. So they test, operate, maintain and ensure that the efficiency, safety and reliability. For example, running the conveyor system in production and they need to troubleshoot the fault occurs in the conveyor system. So this will be happening in the fourth phase of CDIO model. So if you see the key feature of CDIO model, the CDIO model has four phases: conceive, design, implement, operate, that helps the students to develop both technical knowledge and practical engineering skill through the real world problem solving. So mainly focus on emphasis on hands-on learning and covers the complete product life cycle and also develops already said technical and soft skill and improves the teamwork and communication. If you relate the ADDIE model and CDIO methodology with respect to conceive and design, this ADDIE model has totally 5 phases: analyze, design, develop, implement and evaluate. But the CDIO model has only 4 phases. Now you can see what is the meaning of this ADDIE model and CDIO model, how it can be related. In ADDIE model, analyze and CDIO model, first phase is a conceive. So both analyze and conceive is for identifying the problem. Coming to the design phase, the planned system, and third is the development phase. In development phase of ADDIE model, but whereas in CDIO model, it's an implementation phase. So we need to start integrating and building the solution for the particular problem. And ADDIE model, the next phase is the implementation phase. The CDIO model is also has an implementation, because after building, we need to deploy the system into a particular application. And final is the evaluation phase, and here CDIO model, final is the operate phase. So evaluate and operate both has a meaning of test and optimize the system. So if you look at the ADDIE model, the ADDIE model is an education focused system, whereas the CDIO model is an engineering or an industry focused system. But both are iterative problem solving models for engineering. So for the same example, we'll see how to fit this CDIO model. So already we discussed ADDIE model for ball balancing system. Now we'll see how the CDIO model is fitted to the same ball balancing system. So if you look at the step-by-step design process, the first phase is a design problem identification phase. The problem is maintaining a ball at the desired position on the beam. If you look at the requirement, we need to stabilize the system and increase the system response, the fast response and minimum overshoot. So these are the requirement of the ball balancing system. We have to maintain the stability. The system should respond quickly, and the system should have minimum overshoot. So what is the concept generation here is this a concept generation phase. So in this concept generation, first we are going to develop a PID controller and the servo motor for a beam tilting. So servo motor is mechanically coupled with the beam. Whenever the servo motor rotates, the beam will have a tilting effect. Based on the tilting effect, the ball can move here and there, and finally it will be maintained in the centered position with the help of PID controller. Then the design phase, the design phase, we are going to first identify what are the components we are going to use. We are going to use a sensor, controller, actuator. The sensor we are going to use ultrasonic or IR sensor for position detection. Controller we already identified as a PID controller, and actuator is a servo motor. So they're using these components. First we have to design the system. So after designing the system, we need to implement with the controller. So the implementation, we are going to use Arduino based controller plus servo motor and sensor, and we are going to have a feedback loop. So based on the ball position from the ultrasonic or IR sensor, we have to adjust the servo motor. The beam can tilt here and there, and finally it will be settled at the center position. The ball will be settled at the center position. So in the implementation phase, we are going to implement a real feedback controller to maintain the ball at the center position. So the last phase is a testing phase. In the testing phase, we have to tune the PID gain value. So as I already mentioned, the ADDIE model, we have to tune the proportional integral and derivative gain values. Based on this tuning parameters, we can observe the requirements. We given three requirements: stability, fast response, and minimum overshoot. So those response can be easily observed by changing the proportional integral and derivative gain values. So tuning this PID gain values one by one, and look at the or observe the response time, how your system is getting oscillated. Oscillation means the ball can move here and there, left to right on the beam. So we have to minimize the oscillation, because otherwise the ball will have a overshooting effect. So we need to minimize the oscillation, and also how quickly the ball gets settled at the center position. That is reduces steady state error. So all these parameters we need to noted in the testing phase. So the CDIO model and the ADDIE model is given application as a ball balancing system. For both the cases are basically used in the engineering design process.